Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the amines and its basic nature. So coming to the amines, these amines can be considered as the derivatives of ammonia. So whenever one or more hydrogens of ammonia are replaced by the alkyl or aryl groups, then it results in the formation of amines. So, how amines are obtained? By the replacement of one or more hydrogens by alkyl or aryl groups, it results in the formation of amines. So, whenever one of the hydrogen of ammonia is replaced by the alkyl group, then it results in the formation of primary amine. In the similar way, if one of the hydrogen of ammonia is replaced by the aryl group, then it results in the formation of aryl amines. So, amines can be classified into two categories: alkyl amines and aryl amines. Again, these alkyl amines and aryl amines can be classified into three categories depending upon the number of alkyl groups or aryl groups present in the amines. Let us see the classification of alkyl amines. So alkyl amines, again, they can be classified into three categories, namely primary amines, secondary amines and tertiary amines. So, whenever if one of the hydrogen of nitrogen is replaced by the alkyl group, then it results in the formation of a primary amine. If the two hydrogens of the ammonia are replaced by the two alkyl groups, then it results in the formation of secondary amine. And similarly, if three hydrogens of the nitrogen of ammonia are replaced by the three alkyl groups, then it results in the formation of tertiary amines. So, in the similar way, if the hydrogens of ammonia are replaced by aryl groups, then it results in the formation of primary aryl amines or secondary aryl amines or tertiary aryl amines. So, depending upon the number of alkyl groups or aryl groups, amines can be classified into primary, secondary and tertiary. Is it clear about the primary, secondary and tertiary amines? With respect to the amines, the basic nature of amines is very important. So, now let us discuss about the basic nature of amines. These amines exhibits basic nature, and the basic nature is mainly due to the presence of lone pair of electrons on the nitrogen of the amines. So these lone pair of electrons are readily available to donate to the other compounds, and hence amines are basic in nature, and these amines are capable of donating lone pair of electrons, means they can be considered as Lewis bases. So simply Lewis, these amines can be called as Lewis bases. Let us compare the basic nature of amines with that of ammonia. So whenever if we consider ammonia, Its formula is NH3 and nitrogen is having one lone pair of electrons. And coming to the primary amine, here one alkyl group is present. Still the nitrogen atom carries one lone pair of electrons. And due to the presence of alkyl group, which is plus I affecting group, it donates electrons towards the nitrogen. With the result, the electron density on the nitrogen increases. So whenever if we compare the basic nature of ammonia with that of primary amine, due to the presence of plus I affecting group in primary amines, the primary amine is more basic than ammonia. And in the similar way, we can compare with secondary and tertiary amines. So, in the case of secondary amines, two such alkyl groups are present. With the result, what happens? We are having two plus I affecting groups. With the result, the electron density on the secondary amine is much higher than the primary amine, and hence secondary amines are more basic than primary amines. And similarly, when we consider tertiary amines means the three nitrogens of the ammonia are replaced by the three alkyl groups. So these three alkyl groups donates electrons towards the nitrogen atoms, and hence the electron density on the nitrogen is much higher when compared with the secondary amine and also primary amine. So with the result, these tertiary amines are much higher basic than secondary amines. So whenever if we compare the basic nature of ammonia with that of primary, secondary and tertiary amines are much higher basic than secondary, than primary, than ammonia. In other words, ammonia is less basic than primary amines, than secondary amines, than tertiary amines. Here we can also compare the basic nature of ammonia with that of water molecule. So let us see the basic nature of water and ammonia. So in the case of water, two lone pairs of electrons are present on the oxygen atom. And coming to the ammonia, one lone pair of electrons are present. But remember, oxygen is more electronegative when compared with the nitrogen, and hence the lone pair of electrons present on the nitrogen are more readily available than oxygen itself. With the result, ammonia is more basic than water. Clear, students? So ammonia is a stronger base when compared with the water. Clear, students? And remember that here we can also study the basic nature of aromatic amines. So what is the good example for aromatic amine? Aniline is good example for aromatic amines. So in the case of aniline, here the nitrogen carrying lone pair of electrons is directly attached to the benzene nucleus. With the result, what happens? These lone pair of electrons will be involved in the resonance with the benzene nucleus. With the result, these lone pair of electrons are not readily available for the basic nature. Hence, aniline is less basic than ammonia. Let us see the resonance structures of aniline. So, whenever NH2 group with lone pair of electrons is in resonance with the benzene nucleus, then with this pair of electrons, a double bond will be present between the nitrogen and the carbon atom of the benzene. And hence, the bond pair of electrons are transferred to the adjacent carbon atom. Let us see the resonating structures of aniline. And hence, this carbon atom carries the negative charge. And there will be no change in the position of remaining double bonds. And hence, this negative charge is capable of forming a double bond between these two carbon atoms, and hence this bond pair will be transferred to the adjacent carbon atom. With the result, a double bond will be present here, and this carbon atom carries the negative charge, and there will be no change in the position of other double bond. And in the next step, this negative charge forms a double bond between these two carbon atoms, and this bond pair of electrons will be transferred to the adjacent carbon atom. And the resulting resonating structure is double bond NH2. Here a double bond is present. A double bond is present between these two carbon atoms, and this carbon atom carries the negative charge. Remember that the nitrogen is donating electrons for the formation of a double bond between the nitrogen and the carbon atom of the benzene nucleus. With the result, this nitrogen carries the positive charge. So these are the resulting resonating structures due to the presence of nitrogen with the lone pair of electrons in conjugation with the benzene nucleus. So from these resonating structures, it is very clear that the lone pair of electrons present on the nitrogen are not readily available. With the result, aniline is less basic than ammonia. So, the basic nature of aniline is less when compared with the ammonia. Is it clear? Next, we will compare the basic nature of ethylamine with that of aniline. So let us compare the basic nature of ethylamine with that of aniline. Let us see the structures of both ethylamine and aniline. So in the case of ethylamine, it is C2H5 and H2. And coming to the aniline, NH2 group is present on the benzene nucleus. So in the case of ethylamine, ethyl group is plus I affecting group. So it donates electron pair towards the nitrogen atom. With the result, the electron density on the nitrogen atom increases. But whenever if we consider aniline structure, here the lone pair of electrons are in conjugation with the benzene nucleus. With the result, they will be involved in resonance with the benzene nucleus, and hence the electron pair on nitrogen is not readily available for donation. So with the result, ethylamine is highly basic when compared with the aniline. So we can also compare the basic nature of ethylamine and aniline with that of ammonia. So definitely ethylamine is highly basic than ammonia than aniline. Is it clear, students? So here in the case of ammonia, the lone pair of electrons are available. But when we compare ethylamine, due to the plus I affecting nature of ethyl group, the electron density on the ethylamine increases, and hence ethylamine is highly basic than ammonia. But when compared with aniline, here due to the presence of conjugation, here the lone pair of electrons are not readily available, and hence aniline is less basic than ammonia. Let us see the effect of substituents on the basic nature of aniline. So, what is the present concept, students? Let us see the presence of electron donating group on aniline. So, if at all an electron donating group is present on aniline, how it influences the basic nature? Let us see. So, electron donating group means generally it may be a plus I affecting group. If at all a methyl group is present, then what happens? It donates the electron pair towards the benzene nucleus, with the result when compared with the aniline. Let us compare with the aniline. This nitrogen experiences much higher density, and hence electron donating groups, because of the plus I affecting nature, it increases the electron density on the nitrogen. So definitely electron donating groups increases the basic nature of aniline. And let us see the presence of methoxy group on aniline. So if at all methoxy group is present on aniline, then what happens? Due to the presence of methoxy group, it exhibits plus M effect. So it is capable of donating electrons towards the benzene nucleus, with the result the electron density on the nitrogen also increases, and hence it is also much higher basic in nature when compared with the aniline. But when we compare the basic nature of alkyl substituted aniline with that of methoxy substituted aniline, the methoxy substituted aniline is more basic than methyl substituted aniline than alkyl group. Here the electron density increases due to plus I effect, but whereas in the case of methoxy substituted aniline, the electron density increases due to plus I effect, which is more dominating, and hence methoxy substituted aniline is more basic than methyl substituted aniline than aniline. Next we will discuss about the influence of electron withdrawing groups on the basic nature of aniline. So whenever electron withdrawing group is present, then how it influences the basic nature. So the presence of electron withdrawing groups. Let us consider the presence of nitro group on aniline. If at all nitro group is present, then what happens? Remember, nitro group is electron withdrawing group, with the result the electron density on the nitrogen of the aniline decreases. So electron withdrawing groups will decrease the basic nature of aniline. So that means aniline itself is more basic if at all an electron withdrawing group is present on aniline, and depending upon the position. So the adjacent position is called as ortho position. Next one is called as meta position, and the opposite position is called as para position. So the influence of electron withdrawing group varies depending upon the its position. So here when we consider aniline, aniline is ortho and para directing group. So if the substituent is present in the ortho position, the effect is more. And the next position is para position. So if the substituent is present in the ortho position, its effect is more, and the second position is para, and the third position is meta position. So if the nitro group, that means electron withdrawing group, is present in the ortho position, then the basic nature of aniline will be decreased to the greater extent than in the para position, than in the meta position. So if the electron withdrawing group is present in the ortho position, its basic nature will be decreased to the greater extent than in the para position, than in the meta position. So here we can say that aniline is more basic than metanitroaniline, than paranitroaniline, than orthonitroaniline. Students, is it clear about the basic nature of aniline and how the presence of electron donating groups and electron withdrawing groups influences the basic nature of aniline? Always remember the fact that electron donating groups increases the basic nature of aniline, whereas electron withdrawing groups decreases the basic nature of aniline. And remember that alkyl amines are more basic than aryl amines. I think that is enough about the basic nature of amines. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.